Hello, I am Aurélien Personas from CNRS, and I'm going to talk to you about DORA the Explorer, an application we've developed to showcase interactive deep reinforcement learning for exploring very large datasets. Data exploration on very large datasets depends on data and scenario complexities and on the user ability to express their needs. The exploration scenarios range from looking for a needle in a haystack to finding clusters of objects. So we need an integrated framework to experiment with multiple machine learning-based exploration policies. DORA the Explorer is an interactive data exploration system that provides users with a full spectrum of exploration modes on large datasets, driven by data familiarity and curiosity and opportunistic user interventions. DORA is based on exploration pipelines. An exploration pipeline is a sequence of exploration operators closed under a set-based semantics. This is the interface of DORA. In the A zone, we show the current pipeline that has been executed so far. The B zone shows the results of the last operator executed. The C zone allows the user to select the exploration mode, ranging from manual exploration to fully guided exploration, and the model selection, each model providing a different exploration strategy. The D zone is the operator selection, allowing the user to select the next operator to execute and its attributes. The E zone allows the user to save the pipeline, to load the previous pipeline, or to restart the session. In DORA, we start by preprocessing the dataset we want to explore to extract item sets that will be used for exploration. The user can then access the interface to execute pipelines and operators to explore the item sets that are stored in memory on the server. To develop the different training policies, we use A3C deep reinforcement learning agents, accessing the application through an environment interface, allowing the agents to use the application in the same way a user would. The exploration policies training aims at developing various exploration strategies to guide the users in various ways. To do so, we train models with a mix of different objectives. The first one is the data familiarity, consisting in finding a predefined set of items of interest in the dataset. The second one is curiosity, aiming at bringing the user to new and unknown results in the application. Each model runs offline thousands of pipelines trying to fulfill those objectives, resulting in various exploration policies. The user can then select the most adapted model to guide him in his exploration session. So let's take a look at the application. We will start the demonstration with the manual exploration mode. In the manual exploration mode, the user completely controls his exploration session and does not receive any kind of guidance. We have to start the exploration session by a bifacet, which will split the entire dataset on a provided attribute. We will use the magnitude Z. DORA the Explorer currently runs on a subset of the SDSS datasets containing 2.6 million galaxies. We're using 7 exploration attributes. We have selected the color magnitudes, the compacity of the galaxies, and the redshift, indicating how far a galaxy is from the Earth. In the current pipeline area, we can see that we have executed a bifacet. In the current operator results area, we have the item sets resulting from the previous operation. Each line in this area is a different item set. Here we can see that the first item set is 261,000 galaxies big. Each item set is defined by a list of attribute values that are shared between every item of a set. At each step of his exploration session, the user has to decide which sets he will use as inputs for the next operation and the next operator he wants to execute and the attributes of this operator. In this case, we will use this set as inputs and we will split it on the G magnitude. Each resulting set will share the attribute values that are defining the input sets and have a different range of values for the G magnitude that we used as an attribute. The user can also use the partially guided mode. In the partially guided mode, a pre-trained model having a pre-trained exploration policy will suggest the user an input set, an operator, and its attributes. The user in partially guided modes is able to change the input set if he thinks another set is of interest, and even to change the operator to execute. Here we will execute a by superset, which will return the 3 smallest item sets fully containing the input set. At any time, the user can decide to change his exploration strategy by selecting a different model for exploration. For now, the user can only select a different curiosity weights. The curiosity weight represents the ratio between data familiarity and curiosity that was used for the training of a model. The new model will then select different input sets and operator, each model having a different exploration strategy. The user can also decide to use the fully guided mode. In the fully guided mode, the user does not decide anything and everything is controlled by the model. At any time, the user can decide to stop the exploration and to change to another exploration mode or to change the model he uses for guidance. The user can always access some information about the training of the model he uses for guidance and about the pipeline he's executing. The user can always save the current pipeline, load the previously saved pipeline, or restart his exploration. DORA is available online, and the code is fully available on GitHub. If you want more details about our work, we have an accepted paper at the AIDM workshop of the SIGMOD conference. The paper is called Balancing Familiarity and Curiosity in Data Exploration with Deep Reinforcement Learning. Thank you for listening.